Hello students.
And all the listeners. So today we are doing some numerical based on Gauss theorem. One of my students has asked me to solve this numerical in which this is a cube. This is a cube of side A. This is a cube of side A and placed at distance A from the origin. And and this cube is placed in an electric field. This cube is placed in an electric field E. Electric field E is equal to Cxi. Cxi, where C is a positive constant. Where C is positive constant. Okay. Then we have to find the electric flux through the cube. Find out the electric flux through the cube. So we will solve it using an Gauss theorem. And the second one, we have to find the net charge inside the cube. Net charge inside the cube. As you can see, this electric field, which is given by Cxi, as you can see, the electric field is along the positive x direction. This electric field is E, which is along the positive x direction. This one is positive y direction, and this one is positive z direction, because the unit vector is I cap. So the electric field is along the positive x direction. So net flux we have to calculate. There are 6 faces of the cube marked as 1, 2, 3, 4, 5 and 6. As in case of your room, there are 6 faces. Okay. The area vectors of these faces are, the area vector of face 1 is along this direction. The area vector of face 2 is along this direction. The area vector of phase 3 is along this direction, and the area vector of phase 4 is along this direction. Similarly, the area vectors of 5 and 6 are also perpendicular to the faces. Now, as the direction of the electric field is along the positive x-axis, then the area vectors of phase 3, 4, 5 and 6, you can see these area vectors are perpendicular to the electric field E. So using this E dot ds for the phases 3, 4, 5 and 6, 3, 4, 5 and 6, this comes out to be 0, because E dot ds because E dot ds is EDS cos theta, EDS cos 90. Okay, and as you know, cos 90 is 0. This one is 0. So whole the term is equal to 0. So this term E dot ds, which is known as electric flux through these four phases 3, 4, 5 and 6 will be equal to 0. So there is no contribution towards the flux of these four phases 3, 4 and 5, 6. Okay, now we are left with only two phases, 1 and 2. Okay, now we will find out the flux through these two phases. Now you can see the electric field, because the electric field E, this electric field E is along the positive x direction. Electric field E is along the positive x direction. So why the electric flux through the phase 1 enters in the cube and will go out through the phase 2, because the field is from phase 1 to phase 2. So we have to calculate the inward flux and outward flux, and then we will calculate the net flux. Now the electric field E in magnitude is equal to Cx. Okay, we have to find the electric field at phase 1. So at phase 1 the electric field E at phase 1, because the phase 1 is at a distance a from the origin, so E is equal to Ca. Putting the value of x is equal to a, x is equal to a, because the phase 1, this phase 1 is at a distance a from the origin, and at the origin the electric field is 0 because x is equal to 0, and as the x increases the electric field increases. So y the electric field at the phase 1 is equal to Ca. Similarly we can find out the electric field at phase 2, the electric field at phase 2, which is given by E, let it is E2, and the first one was E1. Okay, that it is E2, that will be equal to C into value of x, into value of x. Now the x near the at the phase 2 is equal to 2a. This a plus a, this will be equal to 2a, this distance we have to calculate, c into 2a. So the electric field becomes 2ca, 2ca. Now the electric field, using this electric field and Gauss law, we will calculate the inward flux through the phase 1 and the outward flux through the phase 2. So the net flux through the cube, is given by this relation, total outward flux minus total inward flux. The total outward flux is the outward flux is equal to electric field into area of the phase 2. We'll use this relation E2, area of the phase 2. The area of the phase 2 is a square because the side of the cube is a, minus E1, similarly a square. So This is called comes out E2 minus E1 A square. So as we have calculated the value of E2 and E1, so put the value only. E2 is 2Ca and E1 is Ca and into this one A square. By calculating, we'll get Ca into A square and Ca cube. So the net flux comes out this one, Ca cube. This is our answer for the net flux. Now the second question in this was find the charge enclosed by the cube. Now using the Gauss theorem, the net flux Ca cube, this is the net flux, will be equal to Q by epsilon naught according to Gauss theorem. Net flux or the flux enclosed by a closed surface is equal to 1 by epsilon naught times the total charge enclosed by the surface. So by this we get to know the value of Q, which is equal to Ca cube into epsilon naught. This is the total value of charge enclosed by the Gaussian surface. So basically, Gauss theorem is very easy to apply. What is Gauss theorem? Net flux phi E will be equal to surface integral of the electric field intensity. This is the surface integral, which is equal to total charge enclosed by the surface divided by the permittivity of the medium. That is phi is equal to Q by epsilon naught. To find the Q, to find this Q, find first flux, and to find the flux, calculate outward flux and inward flux, and you will get to know what is the flux enclosed by the surface. I hope you have understood this. The next question can be, if a charge is placed at one of the corners of a cube, let the charge is placed at this corner, the charge is plus q. Okay, you have to find the flux through this cube. You have to find the flux through this cube. Okay, now we can see the flux phi E according to Gauss theorem is the 1 by epsilon naught times the total charge enclosed by the surface. Now as you can see, the charge q is placed at one of the corners of the cube, and this corner of the cube is shared by 8 another such similar cubes. So q is shared by 8 another cubes of such type. So the charge enclosed by the cube, this cube, the charge enclosed by this cube is equal to q by 8 only. The charge enclosed by this cube will be q by 8 only. Okay, so the flux through this cube comes out to be q by 8 epsilon naught, because put the value of q enclosed is equal to q by 8, this one, in this expression, and multiply by with 1 by epsilon naught. Okay, what if you are asked the flux through one of the faces which are not adjacent to the charge, yani the faces which do not neighboring this charge. Okay, there are three faces which are in contact with this charge. The face 1, this face 1 bottom, this face 2, and this face 3. These three faces are in contact with this charge. Okay, so the next question is, what is the flux through the face, this one 4, which is opposite to the charge 4, 5 and 6 left out faces, one of the face. इनमें से किसी एक फेस से आपको पता लगाना है कि फ्लक्स कितना होगा। अब क्यूब के अंदर 6 फेस हैं। ओके, 3 फेस तो क्यूब चार्ज के एडजेसेंट हैं, नेबर में है एडजेसेंट। ओके, जो एडजेसेंट फेस होता है, जैसे मैं ये मान लेता हूँ, यहाँ पर देखिए ये एक फेस है, यहाँ कॉर्नर के ऊपर आपका चार्ज रखा हुआ है, तो फील्ड लाइन ऐसे जाएंगी और जो जो इसका एरिया वेक्टर होगा वो अपवर्ड होगा, अपवर्ड या डाउनवर्ड जो भी है। तो इनके बीच में जो एंगल बनेगा, यू कैन सी दिस एंगल इज 90 डिग्री। बिकॉज आप अपने रूम में बैठे हुए हैं, रूम की दीवार पे एक नॉर्मल डाल के देखो, और रूम का जो डायगनल है, एक फेस का जो डायगनल है जो चार्ज से निकलेगा, उस डायगनल में, फेस डायगनल में और नॉर्मल में 90 डिग्री का एंगल आपको मिलेगा। सो वी कैन से देयर इज नो फ्लक्स थ्रू द फेसेस 1, 2 and 3. देयर इज नो फ्लक्स through the faces 1, 2 and 3. The total flux, whole of the flux, which is q by 8 epsilon naught, this q by 8 epsilon naught of the cube is going through the phase 4, the phase 5 and the phase 6. Okay, it means this q by 8 epsilon naught, this q by 8 epsilon naught flux is divided into 3 phases. So if you are asked to find the flux through the phase 4 or phase 5 or phase 6, one of these phases, then what will you do? You will do nothing but only divide the net flux of the cube by 3. So this is the flux through one of the phases, either it is 4 or 5 or 6, flux through the phase 4 or 5 or 6. It means net flux was q by 8 epsilon naught and divide it by 3, you will get q by 24 epsilon naught. So the flux through one face of this cube, that is through 4 or 5 or 6, it is q by 24 epsilon naught, q by 24 epsilon naught. Okay, and the flux through 1 or 2 or 3, it is 0. It is 0. So the net flux, which was q by 8 epsilon naught, q by 8 epsilon naught through the cube, whole of the cube, this flux goes out of only through the three faces, namely 4, 5 and 6, which are not in contact with this charge, and the faces which are in contact with this charge, that is 1, 2 and 3, there is no flux because the electric field lines of this charge makes 90-degree angle with the normal through this faces 1, 3 and 2. So I hope you have understood this. What is the application of this Gauss law? How to apply? Now the third one question of such type is, suppose this is a cone and a plus q charge is placed at the base of the cone. A plus q charge is placed at the base of the cone. Okay, and you are asked to find the flux going through the cone like that. Find the flux going through the cone. You have to find out. Now, as you can see, if the charge plus q is placed at the base of this cone, then the net charge enclosed by the cone will be equal to q by 2, because this q charge is contributing only half towards the cone and half of its field lines are going this side out of the cone. Half of the field lines are going out of the cone. Only half of the field lines are going towards the cone. Okay, so the net charge enclosed by the cone is q by 2. So the very easy question, this is very easy, simple, very कैसे करेंगे? phi e electric flux according to Gauss theorem, this is charge enclosed by epsilon naught. What is the charge enclosed? Q by 2. So this is q by 2 epsilon naught. Very simple to use this Gauss theorem. Phi e is equal to q by 2 epsilon naught. Very important question. If the charge is placed at the base, then the net flux will be half of the flux of this charge, because half of the electric field lines are going away from the cone and half of the electric field lines are going towards the cone. So I hope you have understood how to apply the Gauss theorem. तो नेक्स्ट वीडियो लेके आएंगे हम कुछ और टिपिकल एग्जांपल्स के साथ गॉस लॉ के। तब तक के लिए रिवाइज कीजिए, खुश रहिए। थैंक यू ऑल।